Lesson 7, solving problems for polynomial functions. So you can solve problems that are linear, quadratic, and cubic. You just have to manipulate the equation. So first, a tub of water is being emptied at a rate of 0.5 liters per minute. The tub has 14 liters in total. So we want to determine an equation. So because we're starting with 14, that would be our y-intercept. And because it has a rate of 0.5 and it's emptying, our slope would be minus 0.5. So we put it into y equals mx plus b. We have y is equal to negative 0.5x plus 14. So that is our equation. We want to figure out when the tub is empty. So our x is representing the time, and it is our independent variable, and the y is showing how much volume is in the tub, volume of water. So if we want to figure out when it's 0, we want to find when y is equal to 0. So we have 0 is equal to negative 0.5x plus 14. We want to minus 14 from both sides, so we have minus 14 is equal to negative 0.5x. Divide by negative 0.5. So the tub will be empty in 28 minutes. And for the last one, we want to know how much water's in the tub after 4.5 minutes. So we're going to make x equal to 4.5. So we have y is equal to negative 0.5 times 4.5 plus 14. So y is equal to 11.75 liters. So when you type that into your calculator, that's what you would get. So that is how you would manipulate that equation. Example 2, a person is on a bridge and throws a rock up in the air as high as they can. This is the formula for height and time, where h is the height in meters and t is the time in seconds. So we want to figure out how high the rock is after 2 seconds, so we're going to plug in t to be 2. So h is equal to 30 plus 12 times 2 minus 3.7 times 2 squared. When you type all this into your calculator, you should get 39.2 meters. So that is how high the rock would be after 2 seconds. We want to figure out when the rock will be 35 meters above the river. So that means our h is 35. So this is a little bit different because we are looking for t, and we have a t that is squared. So what we have to do is we need to move everything to one side and then factor or use the quadratic formula. And because there's decimals and because it's a word problem and it's asking for to find it to 2 decimal places, that's hard to say, you're going to use the quadratic formula. So first we're going to minus 35 to both sides. So we have 0 is equal to negative 5 plus 12t minus 3.7t squared. Now we can find our a, our b, and our c value. Remember, a is with our squared term, b is with our not squared term, and c is our constant value. It is by itself. So we're going to plug this into the quadratic formula. I'm just going to erase this so I have some more room. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So you have negative 12 plus or minus the square root of 12 squared minus 4 times negative 3.7 times negative 5 all divided by 2 times negative 3.7. And now I would ask you to simplify the radical in your calculator, so you should get negative 12 plus or minus the square root of 70 over 2 times negative 3.7 is negative 7.4. So we have two answers. We have negative 12 plus root 70 over negative 7.4, and we have negative 12 minus root 70 over negative 7.4. When we simplify with the plus, pause the video and type that into your calculator, and also type the negative in to see if you get the right answer. So to 2 decimal places, you should get 0.49 and 2.75. So those are the 2 seconds where it would hit 35 meters. So what that means is it hits it twice. Once on the way up and once on the way down. Okay, the last one is a cubic. So the path of a shot put thrown at a track and field meet is modeled by the function, it's a quadratic function, where h is the height in meters and d is the horizontal distance in meters. Determine the height of the discus when it has traveled 10 meters horizontally. It's supposed to say the height of the shot put. So we have h is equal to negative 0.048 bracket d squared minus 20.7d minus 26.28. So we're just going to plug in our distance to be 10. So it's negative 0.048 times 10 squared minus 20.7 times 10 minus 26.28. Simplify inside your brackets first and you should get negative 0.48 times negative 133.28, and when you times this you should get 6.39744. So that would be the height of the discus after it's traveled 10 meters horizontal.